Welcome back, everybody. Let's go back to orthographic view one more time. Orthographic view, we have three major views. The front view referred to as the front elevation, and the right side view referred to as right profile, and the top view drawn to ensure adequate representation of the object. And the front and the side are beside each other and have the bottom aligned. Let's go through some of the good example here, and the viewing plane in the normal position. As you can see, the first view here, and this is at the normal position, and then there's no way to fully distinguish this without additional information if you just provide it with front view, and this orthographic view of the object cannot be distinguished what's going on with the top and the side view, so you need additional information here. And the reason why I'm saying that is because if you look at this object here, let me make a better pinpoint here. And if you look at this object here, this object is look alike with this object. And as you can see, the front view, they have the identical front view. Look at this, and this. A, C, E, they all have the same front view. As you can see, there's an L shape there, and even this object there, 1, 2, 3, 4, they all have the same front view. However, if you look at the shape of the object, they're not the same object. As you can see, this object here, they have an L. Here is L and then a rectangular shape here, whereas this object here is the L shape is the other way around, and this object here is the L shape is kind of inclined, and this L shape with a with a triangle shape at the base. So as you can see, the shape is not the same shape. However, they have the same kind of front view. That's confused everybody. So the only thing we have to do is to add another view to ensure that to give you more accurate information. So the top view will be the best thing. Top view and the side view will be able to distinguish the shape of the object. So if you look at the principal view here, the principal view's plane are perpendicular to each other. Arrange the front view first, which should show the most characteristic. And you can see from here the fold line. When you look at the fold line, and this plane here is to show the front view, and this plane here to show the side view, and the flow line is acting like a hinge where they can, you can turn them around, and then what you're gonna do is to with a fold line, if you unfold it, this is the one that they actually fold two different planes. But if you unfold it, you're gonna see this view, and the position this view C and projecting feature from one view to the next view, but then D, E, F are not the correct positioning of the view. If you look at that, they're not. This is the correct view. View C is a correct view, is a correct projecting feature from one view to the other view, but then D, E, F are not. So continue on the positioning of two adjoining orthographic viewing plane. Again, you have this. The flow line is right here. The right side viewing plane is right here. The front viewing plane is right there. And when you flatten that plane, you're gonna see that two views here: the front view and the side view. And the view without the border viewing plane are early identified as imaginary. Therefore, the flow line is imaginary as well. Often the flow lines are needed for view construction. In general, flow lines are removed on technical drawing. So you don't have to show the technical drawing, and you don't have to show the flow line on the technical drawing. And viewing the plane and image, orthographic drawing omitting the viewing plane. And these two orthographic views that do not completely describe the object. So here, two view drawing and should be sufficient to at least two views are required to show what exactly the shape is going to look like. The top view is not needed at this point. Drawing multi-view projection. Use the fewest number of views to represent an object. A line view with top above the front and right side to the right of front. Use additional view only if a feature is not adequately shown by 3 principle. You need additional view only if it's not enough information. You can't determine what exactly the shape like, then you need additional view. For example, the top view. For this example here, you don't need them because you already, with this two view, you'll be able to see what exactly the top view is. And for example, this orthographic view of an object, as you can see, the front view and the side view, they're all identical. However, the shape of each object are not. As you can see, this object with a triangle base, and whereas this object with a semicircle base, and then this object here is with a triangle. See, and if you compare this object, the semicircle with a triangle, they have the identical front view and the side view. But then if you don't give them a top view, then this top view here, if you don't give them top view, you won't be able to know exactly what is the shape it's going to look like. So the best way to do, you need one additional view to determine what exactly the object is going to be. For this particular case, as you can see, the semicircle, and this semicircle, if you provide the top view, you should be able to see, you should be able to tell what exactly the shape the object looks like. The third viewing plane is commonly used to ensure adequate definition of the represented object. The third view plane is usually above the object and perpendicular to the other two. It's called the top view. And here, again, without the top view, you could mistakenly identify this object as a triangular base, but then this could be a semicircle base. So a top view, the third view is so-called a top view, and the top view is sometimes called the plane view in construction-related drawing. The three viewing plane are called principal viewing plane. So these are the three principal viewing planes, as they are all perpendicular to each other. Oriented the front view first. Always put the front view first. So if you look at that, you have a top view, front, and the side view. And other principal plane complete the box that make up the side of the transparent box that completely surround the object. If you look at that, so this box here, top, bottom, side, front, back, and surround the whole object with all this different view, you can now identify exactly what the object looks like. And now I'm going to stop here at the orthographic view, and then we're going to continue on with the next video with more information about the sixth principal view.